So this is a short story about how to implement a design in ISE Webpack for a Basys 2 FPGA board, and a Xilinx FPGA. So in the previous example, I had an input that was inverted and inverted again. So it was A out was buffered and not A out was inverted. So that was schematic entry, and you can imagine if your design is more than a little trivial, um, I would just say less than a little trivial rather, this becomes really cumbersome. And so an alternative is to write a program in a language called VHDL or Verilog. In our course, we'll use Verilog. So it's not really a coding language. It's a machine specification language. So we're describing how circuits are laid out. And so some of the ideas you might have from writing computer code um, will be broken in this new context. So I created a project like before, and my top level file was a Verilog script. And when you create a new project, you can define the inputs and outputs. And I did that. It's a simple window. So you're creating a machine, right? So the module example is a machine. And if I want to use that machine many times, I'm going to implement that. So here's my module example. And then my example module has an input, so AN, and two outputs, so not AN and B out, just like before. Now, the wiring is that I'm going to say not A in. Oh, look at that typo. It's out, right? Not A, out. So not A out is the inverse. So this bang operator or exclamation point inverts this signal. So if A in is 1, the bang will make it 0, and there we'll have that. So this is the machine right here, this logical operation. In the same way, B out is going to be the AN signal knotted twice. And since each operation takes a certain amount of time to execute, this can be thought of as a buffer. Not a very long buffer, but a buffer nonetheless. So this module declaration, if I can use that fancy language, is describing the structure of a machine. There are also ways of describing the function of a machine. We'll get into that later. Once you have the machine described, the tool that you're going to use, then you can use it, obviously. And that's another piece of code. And so this piece of code is another module. And what I'm going to do is I'm going to use this machine 4 times. And I'm going to use it on 4 inputs. And I'm going to generate 8 outputs, right? Because the machine takes in 1 bit and spits out 2. So the machine I'm using as example, and the name of the first instance is gate 0. The name of the second instance I'm going to set down on the die, right? The second machine is gate 1. And so maybe this seems a little strange if you're used to calling like a square root function in C, but remember we're laying out hardware. We're not writing code, program instructions rather. The other goofy thing is that I'm not using a UCF file in this design. Instead, I'm just specifying the pins directly. So this input A0 is going to be the switch N3 on the pinout. The input A1 is going to be the switch E2. In the same way, this output B0, B0 is used down here. That's going to be the LED G1 labeled on the printed circuit board. So I'll show you a way. So I've pulled up the Basys 2 reference manual from Xilinx website. If you don't have the PCB handy or you can't read it, The reference manual is great because all of the LEDs that you're using, right, their pin labels are labeled. All of the switches that we're using for input, again, are labeled. So this is the code, and it compiles. So I'll attach a demonstration video in a minute.
So it's a beautiful day before class, and I'm just programming FPGA. So here it is. You see that there are these 4 input lights that are bright. So if I flip the first switch, that first LED bounces. Ditto the second one. Ditto the third. Ditto the fourth. And of course it responds to all the switches at once if you want. And also just a reminder that this design is programmed into volatile memory. So if I turn the system off and turn it back on, the design is lost.